Alright, in this video we just want to do an example problem involving angular momentum calculations. So we have this uniform cylinder, essentially grinding wheel, that has a radius of 28 centimeters and it rotates at 1300 RPM, and we need to calculate the angular momentum of this wheel, and then we want to know the torque that we need to apply to stop this wheel. So in order to get the angular momentum, which we said was I omega, we need to get an I for this grinding wheel, and we need to calculate its omega, because 1300 RPMs is not in radians per second. So the first thing is we remember that an I for a cylinder is mr squared. So for us, this is 2.8 times our r of 0.28 squared. And we can plug this into our calculator. And we take our 2.8 times 0.28 squared, and this gives us a moment of inertia of 0.0784 kilogram meter squared. Now to get our omega is 1300, that's revolutions in a minute. And we know that in 1 minute there's 60 seconds, and there is 2 pi radians per 1 revolution. So essentially we'll take our 1300, divide it by 60, and multiply it by 2 pi. And that gives us 38 radians per second. So to get our L, we multiply our 0.0784 times our 38, and that gives us the 2.99, or roughly 3. And this is units of kilogram meter squared over seconds. And then times your radians. Alright. So that gives us the L of our wheel, the angular momentum of our wheel. So the next part is we want to know the torque required to stop this wheel in 6 seconds. So we know initially our wheel has an angular momentum of 3. So when we want to stop the wheel, that means L final will have to be 0. And we know that our delta t is going to be 6 seconds. The equation that we want to use is Newton's second law for angular rotations, which was the sum of the torques is equal to the change in the angular momentum over the change in time. So in this case, we want to have 0 minus 3 over 6, which means that it's roughly a torque of 0.5 Newton meters negative. And the negative just tells us that the torque applied is going to be causing this object to slow down or rotate in a clockwise fashion. Alright, so we looked at this problem using some of our angular momentum concepts. We calculated the angular momentum for the wheel, for the given wheel, and then we calculated a torque needed to slow this wheel down.